Section 11.3, the ANOVA test. So we've talked about the F value being large and discrediting the null and being small and kind of backing up the null hypothesis. But just like in our other tests, large and small are not easily defined. So we use that p-value in order to determine whether we're going to reject or fail to reject that null hypothesis. So in order to find this p-value, we are going to use that F statistic and that F distribution, and we haven't done this yet, but these are the conditions that have to be met in order to use the F distribution. So you have to have a random sample with independent measures. That's pretty standard. You need to have independent groups. So because we have multiple groups in this case, we have to make sure that they're independent of each other. I'm going to skip to number 4. Number 4 is the same as in chapter 9. So we have to have either a normal distribution already, or we have to have a large enough sample, so at least 25 in each group. And then the new one is this, and it's even underlined, it's homoscedasticity. It is a real word, and it's not spelled incorrectly here. But what homoscedasticity means is that the groups need to have basically the same variance. So they need to have the standard deviations relatively the same. Again, for our class, we usually can wave our hands at the 1 and 2. That's usually either included in the write-up of the question, or we can reasonably assume those things. And we're going to check 3 and 4. And just as a reminder, that F distribution is right skewed and only takes on positive values. Okay, so we can easily check whether it's either told us that they were originally normal distributions or whether the sample is 25 or more. We can easily kind of see that from the data that we've got. But how in the world do we check this homoscedastic condition? So as the general rule of thumb is that the largest standard deviation can be no more than twice the smallest. So AKA, how we usually check this is we take the max standard deviation and we make sure that that is less than or equal to twice the min standard deviation. Okay, so let's just practice this. If we are given this information, it says, are we able to perform a one-way ANOVA test on the following? Why or why not? So again, remember the two that we are in charge of checking are this homoscedastic condition and the sample size. So we don't have any information here about these being normal distributions to begin with. So we would need all of the samples to be more than 25. So here's all of our sample sizes. And what I see is there's a slight problem here. 20 is not greater than 25. The rest of them are okay, but we have this one sample that wouldn't meet that. So that could be a problem. That could stop us in our tracks possibly right there. The other one is that homoscedastic condition. So we would need to check, is the max standard deviation less than or equal to twice the min standard deviation? So all they've given us here, technically we are supposed to be doing the standard deviations. All they've given us here though is the standard error. So do the standard deviations if you've got those. This one doesn't have those, so the only thing I can even check is the standard error. So I would be checking, they've already labeled for me the max and the minimum one. Is 9.28 approximately, is that less than or equal to twice the 1.73? And I can tell even without doing that it's not, but 9.28 is certainly not less than or equal to 3.46. So it fails both of the conditions that we need to check. This one right here is more, this one is more of the showstopper. Sometimes whenever we encounter this, we can assume normality to continue.